Have you ever dreamed of floating, weightless, just like an astronaut in space? Or maybe you've seen sci-fi movies with levitating cars and wondered, could that actually happen? The key to these fantastic ideas lies in understanding one of the universe's most fundamental forces, gravity, and its elusive counterpart, anti-gravity. So, what's the real difference? Let's break it down. First, let's talk about gravity. We experience it every single second of our lives. It's the invisible force that keeps our feet planted firmly on the ground, holds the moon in orbit around the Earth, and keeps the Earth itself revolving around the sun. Albert Einstein revolutionized our understanding of gravity with his theory of general relativity. He proposed that gravity isn't a force in the traditional sense, but rather a curvature of space-time. Imagine placing a heavy bowling ball on a stretched-out rubber sheet. The ball creates a dip, a curve in the sheet. Now, if you roll a smaller marble nearby, it won't travel in a straight line. It will curve towards the bowling ball, following the dip. That's essentially how gravity works. Massive objects like planets and stars warp the fabric of space-time around them, and other objects simply follow these curves. So, when you drop an apple, it's not being pulled down by a mysterious force. It's following the curve in space-time created by the Earth's massive presence. It's an attractive force, always pulling things together. The more mass an object has, the stronger its gravitational pull. That's why a planet has a much stronger gravitational field than, say, a basketball. Now, let's venture into the more speculative and exciting realm of anti-gravity. The term itself sounds straightforward, right? It suggests a force that does the opposite of gravity. It pushes things apart instead of pulling them together. If gravity makes things fall, anti-gravity would make things rise. Imagine a device that could nullify or even reverse the Earth's gravitational pull, allowing objects to float effortlessly. This is the stuff of science fiction dreams. But is it scientifically possible? Here's where things get tricky. In our current understanding of physics, there's no known particle or mechanism that generates a repulsive gravitational force in the way we imagine anti-gravity. Gravity, as described by Einstein, is a property of mass and energy. All the matter we've ever observed, from tiny atoms to giant galaxies, has positive mass, and therefore creates an attractive gravitational field. To create anti-gravity, you would theoretically need something with negative mass. This concept, often called exotic matter, is purely hypothetical. If you had a ball of negative mass, it would repel other objects instead of attracting them. It would fall up instead of down. While physicists love to play with these ideas in their equations, we've never found any evidence of negative mass in the real universe. So, building an anti-gravity machine that simply cancels out gravity is, for now, far beyond our technological reach, and might even be impossible based on the laws of physics as we know them. But wait, the story doesn't end there. While a simple anti-gravity switch might be fantasy, the universe does have something that acts a bit like it on a cosmic scale. I'm talking about dark energy. Astronomers have observed that the expansion of the universe is not slowing down as you might expect due to gravity pulling everything together. Instead, it's accelerating. The galaxies are moving away from each other faster and faster. The driving force behind this acceleration is what we call dark energy. It's a mysterious, pervasive energy that seems to have a repulsive anti-gravitational effect over vast cosmic distances. It's not canceling gravity locally. You won't float off the Earth because of it, but it is pushing the entire fabric of the universe apart. So, in a way, a form of anti-gravity does exist, just not in the way sci-fi portrays it. It's a property of space itself, not a technology we can harness. So, to sum it all up, gravity is the well-understood attractive force generated by mass that curves space-time and holds the universe together. Anti-gravity is the hypothetical concept of a repulsive force that would counteract gravity.